In this lecture, let's store the player's movement. The input system has no idea where a player is. They can be anywhere on the map. Therefore, it doesn't calculate a new position for the player based on their current location. Instead, the information sent by the event will contain a direction. If the input system says to move forward, we'll move the player forward from their current position. If they should move to the left, we'll move the player left. Therefore, the first step in our journey is to grab the direction. This information can be found within the context parameter. Let's remove the print method from the handleMove method. It's not necessary to keep it around. Next, run a method called context.readValue. The readValue method will grab the direction indicated by the controller. The great thing about the input system is that it'll return this information in any format we want. We can specify the format by adding a generic. Let's set the generic to vector2. In an earlier lecture, we briefly got into a discussion on vectors. Vectors are a mathematical concept. Luckily, it's not necessary to be a mathematician to understand vectors. At the end of the day, Unity uses vectors to store the position of a game object. There are two types of vectors, which are vector2 and vector3. A vector2 contains coordinates for objects on a 2D plane. Typically, developers use this type for 2D games. Vector2 contains the x and y coordinates of an object. As for vector3, this type is normally used with 3D games. It stores the x, y, and z positions of an object. Similar to the callback context type, these types are defined by Unity. It can be found under the Unity engine namespace. You can hover your mouse over the type for the full path. Fortunately, we're already referencing this namespace from within our script. We're using vector2 because the player will be moving around a flat surface. They will not be jumping. Let's store this information in a variable. Before running the method, create a variable called input with the vector2 type. The type returned by the method will always be the type of the generic. The next step is to convert the value from a vector2 to a vector3. Sounds strange, right? If we wanted a vector for a 3D space, why don't we update the action to send us a vector3 value? The reason is simple. We don't have bindings for moving the player up or down. Therefore, creating a vector3 would require additional bindings, which we don't have. As a result, we must convert the type from vector2 to vector3. This process is relatively simple. At the top of the class, define a new private variable called movementVector with a type of vector3. At the moment, the variables are local to the method. They won't be accessible outside the method, which can be a problem. In a future lecture, we're going to rotate the player toward the direction they're moving toward. If this information is not accessible to the entire class, this task would be impossible. Storing the player's direction in a variable exposed to the entire class will be easier to work with. Back in the handleMove method, set the movement vector variable to the following value: new vector3 input.x, 0 input.y. A new vector can be created by using the new keyword. This keyword is followed by the type of data we'd like to create. In this case, it's a new vector. Inside the parentheses, we're configuring the initial values of the vector. There are 3 values that we must provide. They're the x, y, and z coordinates. In this example, we're using the input variable to access the x and y coordinates from the vector2 object. The x property is mapped to the x coordinates. The y property is mapped to the z coordinates. Keep in mind, the y coordinate moves the player up and down. Since we're not going to allow the player to jump, they will remain on the ground. We can set the y coordinate to 0. Instead of mapping the y property to the y coordinates, we're mapping it to the z coordinates. Before testing our code, let's log the new vector. At the bottom of the method, call the print method with the movement vector variable. We're not limited to logging strings or numbers. Almost anything can be logged. In this case, we're logging the direction. Let's head back to Unity. Next, switch to the console window. After doing so, play the game. If we were to press buttons on our keyboard, nothing would happen. Why not? Surprisingly, by updating the method's parameters, Unity no longer recognizes it. Let's exit play mode. Next, select the Game Manager object from the hierarchy. Search for the Move event from the inspector. According to the editor, the Handle Move method is missing. However, our script does have this method. The reason we're receiving this error has to do with our updates. By updating the parameters, Unity thinks we've created an entirely new method. Previously, the method didn't have parameters. It's expecting to find the method without the parameters. To fix this issue, we simply must update the event to use our new Handle Move method. Let's quickly update this event. After making those changes, let's play the game. This time, the direction gets logged in the console. We can press a single key or a combination of keys to get a new direction. If we release a key, the vectors get reset to 0, 0, 0. This value indicates that the player should not be moving in any direction. That's going to be helpful later down the line. In the next lecture, let's use this information to move the player in the desired direction.